Okay, so welcome back, and now what we're going to do is we're going to start discussing parametric equations and parametric curves. And so to introduce this, let's talk about spirals, okay? So if we have a spiral like this, then we can describe that spiral using the Cartesian plane, using xy coordinates. But we can much more easily describe the spiral if we had something that was, what's the word I'm looking for? More designed to handle curves like this, okay? And so we have what's called polar coordinate system, right? So we're going to describe, instead of having something like this where we have an xy coordinate system, we're going to use what's called the polar coordinate system. So we're going to describe curves like this by talking about an angle and a point or radius, right? So any point that we normally can describe using xy coordinate system, we can also describe that point by talking about an angle, right? A reference angle, or an angle theta, and the radius of that ray from the origin, okay? And so I find out that if we use the polar coordinate system, then we can describe curves like this that obviously don't represent a function, right, in the case of where we have xy, but we can write it as a function of r and theta, and it becomes simpler, and we can handle it better in the polar coordinate system. So that's where we're going to talk about parametric equations, okay, and the idea of a parametric curve, okay? And so we're going to start with the idea of how do we handle this using polar notation, and then how do we handle this going forward, things like this, how do we handle things like finding the area or the volume or things like that, okay? And so that's what we're going to start with. And so going forward, we're going to introduce the idea of we're going to talk about polar notation. How do we handle polar notation? How do we write things from coordinate rectangular system to the polar system, and so on. And then we'll get into integration and using calculus. Okay? Have a great day.